Welcome to Anotalk, the official podcast of the Alumnium Anodizers Council. Dive into the fascinating world of aluminum anodizing, the technology that makes aluminum look like aluminum. Whether you're an industry professional, a curious newcomer looking to add color to your aluminum projects, or just someone who thinks running electricity through metal and acid sounds fun, this is the podcast for you.
All right. Well, thank you all the millions and millions of listeners of our podcast for listening into part one of our podcast with Anne Deacon Juhl. It's always great to meet another industry expert on the anodizing side. I thought it was always good to get a European influence too, which I think it maybe classes us up a little bit, guys, from a culture perspective.
Should we start putting on like English accents?
Some sort of accent, because I definitely felt like I was on the defensive when I was talking to her. It seemed like, she really sounded smarter simply based on the fact she didn't have my accent.
Well, you know what's interesting about all this, gentlemen, if I might add, I would add a couple of things. First off, with her experience, it's always good to hear what she had, what she's seen, don't you think?
Yeah, well, absolutely.
Nice of her to share some of her background.
Yeah, it's funny how whenever we bring these kind of industry leaders on, the stories that get them into anodizing, because it's always the path's never the same. There's always a nuance to all of them, so it's pretty cool. And then one more thing to add for those of you who aren't seeing the video of us, the head garment game by the three of us is probably the best it's ever been in our podcast. So if we are able to show the video of this, I highly recommend that, because we really don't get to show off the top of our heads that often. But in all seriousness, go for it, Mark.
If you don't mind, Tage.
Sure.
This is my ode to Dan Bishop, because he always has one of these kind of hats on. Right?
Oh my God, you're right.
You know what I'm talking about, right, Dr. O?
I do.
For audio viewer or listeners, I want to be clear. Mark looks like a member of the Peaky Blinders right now, just so you can you all can pull over the side of the road and take it in. He looks like a member of the Peaky Blinders. It's amazing.
The shirt and everything too. Oh my God.
Almost as amazing as part two of this podcast, which is going to be Pulse Anodizing. So I encourage everyone to tune in. Mark and George, anything you guys want to weigh in on the trailer for this Pulse Anodizing podcast? I'm excited.
Wait, are you telling me to tune in too?
Oh,
I thought it'd be a compliment. I'm confused, Tate.
We can listen to ourselves again, Mark.
That's exciting. That screws me up when I hear ourselves talk.
No, it'll be a good learning experience for those of you who have not or are unaware about Pulse. It's an interesting process, one that I think wrapping your head around is going to be valuable for you. So we look forward to sharing that with the rest of our audience.
Perfect. Tage, you did that so well, and you teed it up so nicely. And for those that are not viewing, and this is audio, Tage is sporting this red knit hat, and Dr. O is sporting the Quaker Houghton baseball cap with blue.
With the official logo on it. Let me Vanna White this a little bit more. Yeah.
It is pretty impressive what we got going on here today.
And it's so nice also we've stepped up the podcast game, right?
Yeah.
Oh yeah,
it's elite level. Elite level. I think podcasts are we're approaching the cutting edge now, boys.
So explain what pulse anodizing is and how it differs from traditional anodizing, like a day one person coming in trying to learn about the anodizing process.
Yeah. The really, really great part, it's my baby, so now you really have to stop me. I'm telling you.
Never.
Yeah. So the reason why pulse anodizing, I think is the best way to do pulse anodizing. As I mentioned in the beginning, in the other part.
Wait a minute, let me stop you right there, because
False false start. Hold on.
Yeah, bring one.
Hold on.
I think what I heard you say is I think the best way to, what is the pulse anodizing is pulse. I'm confused, but go ahead. Want to try it again?
Okay, so let me help you. Pulse anodizing is just a way to, instead of having a direct current, so you're just applying a certain amount of current, 15 amps per square feet, and you continue using that the whole time. Or you're applying 15 volts, and you're doing that the whole time.
Mm-hmm.
By pulse anodizing, you start changing the current to different values. So it's kind of like, you know about ramping. A lot of people do ramping.
Well, why don't you explain that, Ann? Let's not assume we might have.
So, yeah, because some of us know what ramping is, and then there's anodizers who think they know what ramping is. So you may want to educate them in this moment.
True.
So what we really like to do is we like to convert the aluminum surface into aluminum oxide. And for not being really pushy, you can say that. So just hammer a high applied current on the surface to have it start converting into the aluminum oxide. Then by ramping, you make it more soft. You make it easier for the surface to be able to figure out, oh, wow, now things happen. I need to change into aluminum oxide. And that makes it even better if you have an alloy. So if you not have a pure aluminum surface, but you have an aluminum surface with different alloying elements on the top surface, and now the current, instead of, as I say, hammering it on, you kind of give it time to say, hey, this is an intermetallic alloys who are working a little different, has a little different conductivity or chemistry difference. So in that way, it creates a slowly starting conversion of the surface into aluminum oxide. I think that is ramping. And then you can do it in many ways, but it's most of the time changing from one step to a higher step of current or voltage, because sometimes it actually makes sense to do the ramping in voltage, even though I don't encourage people to do voltage control.
Well, repeat that. That sounds kind of important.
Don't do voltage control anodizing. Do current control. Even how difficult your parts are, you are still able to calculate the surface area. And that is really something, again, which has changed during the last 5-10 years, that all parts are in a software program. So you can call your customer and say, what is the surface area of my part? So the only thing you, as an anodizer, has to calculate is if you're using aluminum wax.
That is so. I just learned the other day there's free software out there that you can transfer the step file into. It'll tell you how many square inches of surface area you have.
Exactly. Yeah. So it's so much easier, and I'm really something I try to convince anodizing company when I visit them, say, even though you're a job shop and you get all different parts, different kind of parts, it's not that easy anymore, that difficult anymore. So you just continue. But that is the reason why, when you do pulse anodizing, it's even more important that you know your surface area, because you really like to, when you do pulse anodizing, the whole idea is to have a higher average current density than the one you normally will use. Because if you have a higher average current density, you will be able to decrease your process time, in that way increase your productivity. So you're just asking, instead of me just continue, ask Mark.
No, I'm curious. So do you think with pulse, are you going to need more volts to drive the amps as your coating thickness gets thicker?
So the voltage depends you can say mostly on the thickness of the coating, because the thickness of the coating is the resistance of the coating.
Yep. Yep.
The resistance, Ohm's law, the resistance has to, it is as it is, no matter if you have done it pulse anodizing or direct or AC or whatever you have done. So the voltage should be the same. And in many ways, if you're doing the pulse anodizing right, you will actually have a little lower voltage compared to what you do with conventional direct current, because you are teasing your interface between the aluminum and the aluminum oxide, which helps you decrease the overall voltage. So that's the reason why there is an energy saving during the process compared to, and together with the productivity saving.
So on that point, Anne, just so I understand it, and I'll try to break it down as for my simple mind. If you have a 1,000 amp load and you run it at 15 volts, and I'm just going to go by watts, right? That's 1,500 watts for that specific load, right? So if it's 1,500 watts doing traditional DC anodizing, when you do pulse, are you using less watts to make the same current? I just want to understand is the wattage that's different, or is it the same wattage, but you're using it in a shorter amount of time, so you're not using as much? I want to understand it from a watts perspective.
Yeah. In the watts perspective, you have to keep, really, because there are several things working in here. So you're actually having a higher current density, but in a shorter period of time.
Okay. That makes sense. So you build the coating faster.
You build it. But the higher current density gives you a higher watts.
Right. Yeah.
So, but you do it in a shorter time. And at the same time, because you do this teasing of the interface between the aluminum and the aluminum oxide, you will actually see a decrease in the volts. Not a lot, but over time, it gives you less. And that's the reason why you're using less energy.
Does that mean that for hard anodizing, pulse would actually save you more energy than for type 2?
See, that is what I had hoped.
Okay, because that would make sense based on what you're saying.
Yeah, and it really makes sense. But now we have to, it really does make sense to talk about energy in anodizing. If you're only talking about energy from your rectifier, you have to talk about energy from your cooling system also.
Okay.
And when you do hard anodizing, you have to cool your solution down to around 0
Celsius. Yeah.
Yeah.
Or 32 Fahrenheit for the American listeners.
Thank you. So
Thanks, Tage.
You are using a lot of energy. You don't have to use as much energy to decrease the temperature from 20 degrees Celsius to 18 degrees Celsius compared to 4 degrees Celsius to 0 degrees Celsius. So the energy you're using for the cooling system is really a lot. And I think that in that way, we really have difficulties to really say if we saw a decrease in energy. There was around 5% in the project I was talking about. But if the rest was actually kind of dissolved into the big picture of the cooling system. And also there are something about, we have said that the voltage is only dependent on the thickness of the coating, but that's not right, because we also have the conductivity of the solution, and the conductivity of the solution is also increasing. You can say the voltage you have to push through. So when you have a very low temperature, you have a lower conductivity, so you have to use more energy to push through the system. So unfortunately, this was a 2 years project, but it was still, there are something which really needs to be, I have talked with one of the professors in Belgium we have had as a presenter also, Iris de Grey, to hear if she wanted to go into a project, a PhD project about this, because it needs to be moved from, I'm sorry again, I try to convince you that the whole real line is a lab line, but we have to put it into smaller tanks so we can kind of much more figure out how this going on, because it's too difficult in the big lines.
So 2 questions then. And if I just want to make sure if I understand you correctly, we're essentially using a higher current density to build the coating faster in pulse. From your testing, has that created a increase in heat, or have you not seen a note? Because obviously when I think of higher current density, I think, oh, the heat's going to increase. Have you seen a significant raising in heat through your testing?
Yeah. And that's the reason why type 2, it's much easier because we have a much more forgiving solution.
Exactly.
I think that is one of the so great question, Tej, because that is probably also one of the reasons why we had difficulties to actually kind of pinpoint what was going on in the hard anodizing, because it's all getting much more difficult to figure out where
to separate. Yeah.
Exactly.
So along those lines, then, obviously, as a chemistry supplier, do you think there may be an optimal acid concentration to run when you run with pulse? For example, instead of your traditional 160 grams per liter, 180 grams per liter, maybe run closer to 200 or 220, which is where then you'll see maybe an even bigger benefit of pulse with a more conductive bath.
I really don't like high concentration solutions.
Okay.
Yeah. There are many reasons, and but I'm not. It will not help you when you do pulsing.
Okay.
Yeah. There's still a little. There's so little in that compared to what's going on in the process, especially in hard anodizing. So I don't think that's the way to go. But I know a lot of companies are using high concentrations when they do hard anodizing. And it's really, you have to be really careful because high concentration means high dissolution.
Yeah. Oh yeah, absolutely.
And we all know that even in an automatic line, you have to put down your load before you start your, push the button to apply the current. And depending on, the way you have load your parts, part of it will really be dissolved by the solution. And yeah, even work if it's more manual or semi-manual, because we also know the way that sometimes the clock is bingling and rambling. is
Sure.
And nobody is going there because right now they are the other end of the line. So high concentration is dangerous.
I got one more question. Sorry, everyone. I know I'm Mark Spencering this interview right now, so just give me a minute. I'd like me. More question. So, in the case of type 2, if you're doing 12 amps per square foot and to build 1 mil or 24 microns, it's roughly 60 minutes. Now, if we did that in a pulsed environment, from your testing, what in order to get that 1 mil, what time span would you be able to achieve from an efficiency perspective?
If your anodizing process tank is running well, so well agitated,
sure,
all those stuff, we say that I would say you can go for 50% time. Yeah. So I don't know if you have read the Light Metal Age article from Dashcore. They actually see this 53.6% decrease in process time when they did pulse anodizing. And that were with their old equipment. So they didn't have to buy a new rectifier or anything. They could use what they have. And one of the reasons, because most of sometimes I'm met by, we are already have full load, so we are using our rectifiers to almost 100%. But that's not, we all know that's not true.
Yeah, that's...
we have rectifiers which are difficult to rack, where you cannot have a full rack. And that was what Dashcore actually saw. So they had profiles they were not able to fill up fully. So suddenly by being able to do 53.6% decrease in process time, they could actually have you can say, a full load through in the same time.
Just to repeat what I think I heard you say, okay, Anne?
Mm-hmm.
So, and anytime we have a podcast where we've already talked about ohms, and I think we're bringing Faraday in here.
Yeah, it's getting pretty intense. Things are getting Mark.
It's
Sensitized. No.
So, constant anodized versus pulse anodizing. What you're saying is with pulse anodizing, one of the benefits we'll see is without adjusting anything, well, we have to adjust something else to do it in half the time, correct? You're just not saying put in a pulse rectifier and what used to take you an hour, 60 minutes, you can now do it at 53% of that or 30 minutes, 27 minutes.
You can do that.
How do you have to modify your rectifier to do that? Because you use the example of that customer using an old rectifier. Do you have to make any changes to it in order for it to pulse?
Actually, you can use a really, really old rectifier where you still have the manual shifting.
Yeah, the rheostats.
You don't have a person standing there, 30 seconds.
So you're just turning it on and off?
Yeah, no, not turning it on and off.
Sorry. Okay,
No.
let's clarify that point.
There's one of the things I did in my PhD. You should not turn it on.
Okay.
You turn on, then the process is getting really you almost have to do the ramping again to get it.
Oh, I see. Yeah, I see.
Very, very small in the slow or the low period. You have to have a low current running, so you have the process going on.
Okay.
Yeah.
Okay. And how big is that variation from high to low? Or how big can it be versus how small can it be?
It can be as big as you want. Isn't it nice?
Wow.
Yeah. No, yeah. It depends. It depends, of course. Now you have to think about your rectifier, because are your rectifier really able to go from, let's say, 50 amps per square feet to 10 amps per square feet in milliseconds? No, probably.
Okay.
So there you have to think about it. So, but I would say that it also depends. And here, even though I have said that anodizing companies look like each other, still, racking and contacts and cathodes and concentration. So there are a variation. So it's not just like, you should start. You can do it with these parameters and they can do pulse anodizing. But there are a place where I always let people start so we can see how their equipment and process is working.
So on that note, Anne, let's just go back to your example of 50 amps a square foot and 10 amps a square foot, or 5 amps a square foot. When you do that, two questions. One, is there a risk of burning because you're going at such high of a current density, A, and then B, do you have to make your tooling bigger to be able to take a 50 amps per square foot current from your testing?
Yeah, and that is the reason why I say 50 amps per square feet. It's really is high, and the things we did with Dashcore was not that high, so you don't have to go that high. But if you want to go that high, there could be many reasons. You want to even decrease the process time even more, for example, in hard anodizing, because you really want to create a very hard layer. So, but then you of course need to make sure that your contact points are able to draw the enough. And you also need to have a well agitated, maybe even agitated even better, as we were talking about the cooling. So definitely in type 3, there are some possibilities also to change the properties a lot, because doing the hard anodizing, also type 2, forget what I was saying. In anodizing, we are changing the structure of the oxide layer depending on what we are pushing through the system. So you can actually play around. It could be when you, for example, do pulse anodizing with type 2 and you want to dye it, organic dye, so only in the top layer. So, but you want to have a layers, maybe only the top or the last part of the process. You do different current density compared to in the beginning. So you can actually start playing around. So you create an oxide layer from the bottom, from the top to the bottom, you can say, and in that way create the size of the pores, the amount of aluminum oxide compared to all these stuff. So it's really a way to play around, and that is also the reason why it can help you when you have difficult alloys. Also, just conventional alloys, which are easy to anodize, because some of them could actually, you could, by pulse anodizing, increase the efficiency even more because it's an easy alloy, which really can handle to have the, for example, 15 amps per square feet.
Sure.
Yeah.
Okay.
So you are, at the end of the day, you are increasing your current density with pulse.
Yeah, the average current density, yeah, because you have a high and a low current density, and the burning part. So the reason why you have the low current density period is what called recovery period. So that's the reason why you don't see the burning. So you have to do the testing, of course. So you see you're running high current density, and then you can see on your online monitoring that something is not happening in your voltage. So now you will actually start increasing your process, to a lower current density. Relaxed, so you didn't have the burning. Then when it's relaxed, you start increasing the current density again, run high current density, and then, now we go down, have it relax and up again. So it's really simple in many ways. So yeah, but I have to say that for so many years I've been talking about pulse anodizing, and it seems like it's only in the last 5 years where people have been contacting me really specific, saying we like to know more about pulse anodizing. And I think that's because we see the energy saving part. We need to think more green and sustainable. I think that's the reason why I see that more. But I also have, again, because I have been able to have a couple of anodizing companies now who have tried to implement pulse anodizing. In the beginning, it was just coming out saying, hey, let's do pulse anodizing. But I have changed idea a little bit, and that's that. Instead of calling it pulse anodizing, I call it Scandinavian optimization process because, I'm sorry, of course, we need to have changes here. But it's also because not to have people think that they can just start immediately with pulse anodizing. You actually need to have a consistent anodizing line running because it really doesn't make sense to start creating all different pulses if you don't know how your line is running.
Yeah.
So if, let's say you're a job shop anodizer, you have 8-foot tanks, your current type 2 rectifier is 3,000 amps, 30 volts. If you wanted to put a pulse rectifier, do you need to have a rectifier specifically for pulse?
No. If it depends on if you're using did you say 3,000 amps?
3,000 amps, 30 volts constant.
Yeah, but if you're on all your loads you're running, if you're using the 3,000 amps already, then you will not be able to do anything with pulse anodizing because you want because then you have to reduce the load.
Square feet. Yep.
It doesn't make sense to reduce the load to get them passed by easier, faster. So it's you need to have a rectifier which has kind of a more
space.
More space.
Yes.
Or if you have the problem of not being able to fill up your loads 100%.
Mm-hmm.
Yeah.
Okay.
But if you fill up 100% and you're using 3,000 amps, you will need to buy a new rectifier or optimize, rebuild your rectifier.
Mm-hmm.
So you can actually put more amps through your line. You don't need to have more voltage because if you're doing type 2, 30 volts, no. But you will need to be able to have higher current density, more amps to put through your line if you're maxed out there.
So are you going to have to add a unit to actually create the pulse?
No, the pulse has nothing. You can with a DC rectifier you can do pulse. The only
Manually,
thing you're asking it is for 30 seconds to do this number 30 and 10 amps per square feet, or for 2 minutes you do 4 amps and 40 amps per square feet, and then you do 10 amps per square feet, and then you do 4 amps. So the only thing you have to do is either do it manually, but most rectifiers nowadays, you're able to actually create the system. So you say you have to do like up and down, up and down. So you don't have to have a pulse anything.
Right.
Yeah.
So like a monk unit, for example, they can program that in there.
Yeah.
Now, the thing that you mentioned this earlier, so we should go back to our viewers and listeners understand this. If you don't have the right surface area of contact between the rack and the part, you can get burning.
And that has nothing to do with pulse anodizing.
Yeah, you can make the argument that's anodizing. Yeah.
Well, I understand, but if you just put that rack in there and then give it a lot of current density and you haven't considered racking, guess what? Right?
Yeah.
You have to, for someone to go out there and say, I'm going to do 30 seconds this, 30 seconds that you make sure your rack is properly set up.
And again, my experience, it's no problem because most of the time the racks can handle higher current density. Maybe not if you go extremely high, but if you have a good racking procedure, so you have good contact points, you can do a higher current density than you think.
So what would you, just thinking out loud here, 3,000 amp rectifier, 30 volts, if you wanted to get 7/10 for a class 1 coating, what would you suggest as far as high current, low current? Just is that something that you could? What would the recipe look like?
Yeah, I would say you can always start easy as you have to go to Light Metal Age and read the article because they actually show the. But
okay.
You can give it here also, so you kind of have a plays around depending on you have to try, but start with 30 seconds, 10 amps per square feet, and then to be secure, not burning, as you say, your racks. Do 30 amps per square feet for a minute and a half, and see what we're giving you.
Right, and then cycle 30-30.
Cycle until you have you calculate the same way with the 7/20 rule, because it's the same. You just do it with the average current density instead of what you normally. So it's not a huge problem or difficulty.
Right. Is there a high end that you would, so don't go over whether it's 40, 30, 50 amps a square foot?
I would say start with 30 amps per square feet. See how your line is working. And then try, and don't try on an expensive customer part.
That's a good tip, man. Or how about 2024? You have any concerns about high copper?
You can do that too, but then you cannot use what I just told you. Then you have to call me, and I will have you.
That's special.
Yeah. So we've got all these, we have these sort of like, how does pulse anodizing work? And you've mentioned that there seemed to be a lot of resistance to people trying to even think about pulse anodizing, like if it's right for their operations until recently. So I guess the question I have is for the listeners, do you have like a rule of thumb where if an operation is like, oh, we're doing this, then we're probably ready for pulse anodizing. Or if they're not doing this, we're not ready. Like, would you say something based on like
a checklist, kind of like, are you ready to do this? A checklist of what you
maybe
need.
a checklist, maybe just like a rule of thumb benchmark. Like if we're doing this percent rework, like we're probably not ready. Maybe something about how often they're checking their chemistries. Like, do you have anything like that they could just say, oh, maybe I'm ready for this?
I like the idea with the checklist. I will write that down because that could be a great, thing to have. I would say you are not ready to do pulse anodizing if you run voltage control.
Mm-hmm.
Okay.
Number one, don't even try. You have to figure out how to work current control before you start doing voltage pulse anodizing. And then I would say, as I mentioned with the Scandinavian optimization process, I really see that you need to have a consistent output on your line. So if you're not able to run the same load twice in a row, then don't start messing around. It's the same. Don't start with a new chemical or anything. If, you have to make sure that you're only changing one parameter at a time. If you don't have a consistency, you have plenty of things which are not working. So don't put pulse anodizing in. Okay. And then I would say the last thing is I would recommend to educate your operators so they understand what the process is, what's going on. So they are not just doing like this, but they actually know what they're doing, because that will help you when you start doing pulse anodizing, because they will be able to come back and see, it seems like it really didn't work with that one and that one. Instead of just trying to push pulse anodizing on them and they really don't understand why. And as I think Tej mentioned, we have been doing this for so long, the tribal knowledge, you have to have the people working with you. So I think those three things, voltage control, consistency, and educated people, are really important if you want to be great with pulse anodizing.
All right. And I would say, honestly, based on my understanding of where the knowledge stands in the industry, a lot of people meet that bar, right?
Yeah.
Yeah. Yeah.
And does the pulse anodize give you a more consistent pour?
You can say you actually change, every time you change the current density, you change the structure of the oxide layer. So from having if you believe you are doing consistency, so you have a straight pour during your process when you do the DC or direct current, you will now have a smaller and bigger. So you have a change in your structure, which is the thing you can play around with. And that is the thing you have to think about when you start doing pulse anodizing and you want to electrolytic coloring your parts.
Right.
So you have to kind of figure out how does that work compared to that you maybe having a more narrow structure in your oxide layer in the bottom of the oxide layer close to the aluminum, and you would like to have a good UV resistant color, electrolytic coloring, then you have some issues. So you have to, and that's the reason why it's not just to do.
Right.
But you have to play and you have to figure out what your line and what your parts and what your, you can say, customer.
Right. Well, let's go down that rabbit hole. So could you set up a pulse to where you're a minute and a half at low current density and then 30 seconds at a higher current density, because light fastness is important? Does that make sense?
Yeah, you can, but you can do you. And again, that's the reason why pulse anodizing is not different from anodizing. That is what you always can do. So if you have a consistency and you have educated people and you know what you're doing in your line, you can actually produce a structure which fits your customers' demand on a clear, beautiful pink color.
Yeah, like Page Pink.
Exactly.
That's a huge dye stuff.
Very popular color nowadays.
But I'm just saying, in that way, pulse anodizing is not something, whoa, it's anodizing. It's still anodizing. You have to think about what structure you need to be able to do or create the properties your customers like. And I think that is the reason why I'm saying with the Scandinavian optimization process, don't even think about pulse until we have the consistency and you know how your line is working. Because it should be like, now you have a customer who would like to have clear blue. Now you would like to have a customer who would like to have high corrosion resistance. Yeah. All comes into how you play around in your anodizing process, not mostly in your process tank, anodizing tank. And I think that is what we back to the mature industry, it's the same. No, this is really, if you see it, you don't have to be passionate, but it's nice if you are, but because it's a playground without, any limit in the way, if your people know how to work it. You can actually be unique in what you're doing instead of thinking you are unique.
Yes. 2 questions then. Bright. So for bright dip, then you want a very bright part. Because when you go high current density, now you're going to dull it down some. Do you see pulse anodizing having a benefit for automotive trim parts and tub and shower door parts?
You are back to when you say bright dip part. So you don't have a very thick layer now.
Mm-hmm.
So what is the thickness we are talking about?
Okay. Yeah, your point. But there's some where we want 7/10 because it's going to go on a building. So we have
20 microns.
Yeah.
20 microns. We gotta be
25 microns.
Yeah, you gotta make sure we talk to both sides of this, Mark.
Yeah. Can we get brighter?
If you can do it brighter, again.
Yes. Can we? Instead of dulling down the anodic coating, the thicker anodic coating, could we use pulse to get a brighter surface?
You can use pulse to do that in the way that, but I don't really want to talk about pulse there. I like to talk about the structure because it depends on how the structure is in your top coating, in the top part of the coating. So all the light is coming in and can be reflected back. And that depends on the structure of the coating. And you can create that with pulse and you can create that with DC. The idea could be that you actually, because the reflection is on the top layer. So you could play around saying, I would like to do pulse anodizing where I create a bigger pore in the beginning of the process. And in the end, we would like to close it down and have a smaller structure, narrow structure, because we would like to have a high corrosion resistance. It should last forever. But that has nothing to do with pulse. It's actually just working around again with your line and playing around with all the possibilities there are to create an oxide film, which are precisely what you want. So
when you create the recipe in a lab, how does it translate over to production?
I don't have a lab, so I'm not doing it in a lab.
So you're doing an actual, so our tanks are 41 feet in length and they're 24 feet in length. But if we wanted to set up a small anodized line where they're 2x2 or 3x3 foot tanks, if you set the recipe in a lab, would that translate well over production, do you think?
Back to if you treat your production as the lab line, you should do that. And that's what anodizers are not doing. They are not treating their line as something which needs to be really, really tight and in control.
Hence, going back to where we originally started, we've done the circle.
Yeah. Well, it's great.
Yeah.
Wow. Okay.
George, did you have any questions? He's taking notes.
No,
I didn't know if he was ready to fire one off.
I think we actually did get to a lot of the things that I was interested in. And Yeah, no, this has been great. Thanks
Yeah,
so
it
much,
has.
Anne.
Yeah, I think it was worth the wait, Mark.
Thank you.
Yeah, mind blown, right? So, and if people have questions and they want to get more information on Pulse,
Yeah.
how do they do that?
Again, they contact me by adj@aloconsult.com.
There you go.
Okay.
I think the first thing they should do is actually try to read some of the articles which are out there about pulse anodizing, because I have actually a lot of free material, finishing and coding, PF online, also Alumnium Anodizers Council. If you are a member, you can read about pulse anodizing in presentations I have had. So, there are a lot of informations out there, but if you want to have specific help, I will be reached by adj@aloconsult.com.
Well, okay, so let's go down another rabbit hole for a minute here. You are involved in IHAA. You're involved in AAC.
Yeah.
And what else?
That is the two organizations, the two anodizing organizations I'm involved.
Right.
Okay. So, but I'm really often writing articles for example, finishing and coding, light metal age, and PF online. So I'm really trying to. I think that is also definitely pulse anodizing is my passion, but being able to help anodizers to be more educated, to know what's going on. This, in my opinion, free knowledge, or, having knowledge out there, creating a bigger pie makes it better for all of us, because anodizing, in my opinion, is the greenest solution if you use aluminum. So I think really that is one of my goals, to try to help and educate and show what's going on in the industry.
I want to follow up then. The two organizations, AAC and IHAA, there's good members involved, but the reach of those organizations, the membership numbers aren't as high as they could be. What do you see the benefit of belonging to those two trade organizations?
You probably already have the feeling that I like to talk. So, so it's not even to be able to have presentations or write articles or whatever, but actually the possibility to be in a place, also like this podcast. When do you have the possibility to talk about anodizing for 2, 3, 4 days without people falling asleep at the table? It's like amazing. So I think that is really one of the benefits. And maybe the number of members, it's I would like to have more members. And there are so many small and mid-sized anodizers in US who are not members of the Alumnium Anodizers Council or International Hard Anodizing Association. And I really think it's a shame, because I think that we should be, as an organization or association, we should be able to reach out much broader. And I don't think we are doing that well enough. And I know there are a lot of things to say about that, and I don't want to go in that rabbit hole. But I really would love if there was a possibility to have a much broader reach that we have in both organizations.
And I would imagine at these conferences, you have people come up to you and they talk to you about challenges in their operation. It's a great networking event.
Yeah.
Do you agree?
Yeah, it is great. And it's also the other way around, because of course it's also nice to be able to help people, but it's also a way for me, and I know also probably also for George and Tej, for the suppliers, because we also here, it's more like a more relaxed setup. So people talk more easily compared to if we come out to them in the anodizing company and they all feel, oh, they're here for selling. But at the conferences, it's much more like, hey, we are talking and, kind of, so we really get a good feeling of what's going on in the industry by being there also. So I think it's really great for suppliers also. I call my sales.
Yeah. Well, a couple Rieslings or a couple of wines or martinis into it.
It's great.
And boy, there's a lot of intelligent conversation.
Well, Mark, you say martinis or Rieslings, but this year's Aluminum Anodizers Council meeting coming up in 2025 is in Atlanta in the Hilton downtown.
Ooh,
but
yes.
one of the claims to fame to this hotel is that it is one of the 2 remaining Trader Vic's tiki bars that are remaining in the United States.
Oh.
Now you asked me, I'm sorry, but I'm from Denmark. What are you talking about? So you will be able to drink for free or whatever?
No, so in the basement there's a tiki bar. So that's
What
where they
is a
have
tiki
like
bar?
Mai Tais and
Oh,
like the little drinks with like the cups and the pineapples and everything.
With an
so you need
umbrella.
to wear best shirt. What is it called? No, we don't need to have other types of clothes on.
Correct.
Tiki.
Clothes are made.
I mean, if you want to wear a Hawaiian shirt.
That was what I was looking for. Hawaii shirt.
Oh, okay.
I'm bringing one.
Optional.
Yeah.
All right.
Perfect. Well, that was great.
Yeah.
And thank you.
You're welcome.
We asked you
Appreciate
the
the time.
time. You built us a clock, for God's sakes. Wonderful.
Great discussion.
Yeah.
Nice.